Okay, for the matrices thing in this mathematical induction, proved by mathematical induction. Let's see how to do that for the matrices. We were given a matrix B, and then we have to prove that the speed is for n is blah 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 here. Okay, so we start. The first step is that we have to prove for n equal to 1. We substituted n as 1, and we got this. And then we have to assume in the second step, we always assume that this is going to be true for n equal to k. So this is our b raised to power k. Uh, we simply substituted n as k into this given expression here. That has to be proved. Now we're going to prove, we're going to prove it. Um, why I'm writing it, let it be true. I have to write here that I have to prove it true for n equal to k plus 1. Now, I have to prove that this b raised to power k plus 1 should be 2 raised to power k plus 1, 2 raised to power k plus 1 minus 1, 0, 1. If I am able to prove this, that means this is going to be true for everything. So now this b raised to power k plus 1, let me change the color so that you don't get confused. So this b raised to, this is my third step being continued here. So b raised to power k plus 1 actually means b raised to power k times b. So I'll be taking b raised to power k from here. So that is 2 raised to power k, 2 raised to power k minus 1, 0, 1 times this b. You can write this b first before this as well, okay? So this is 2, 1, 0, 1. Okay, when we multiply this, the rows into the columns thing, this is going to be 2 raised to power k plus 1 because the bases are same. So this is going to give us this. And then all of this multiplied by 0 will give us 0. Then the next one is 2 raised to power k plus this plus 2 raised to power k. It's okay. Okay, this is minus 1. Okay, and then we go on to the second row to be multiplied by the first column here. So this into this, 0 into 2 will give us 0, 1 into 0 will give us 0, and then 0 into 1 will give us 0, and 1 into 1 will give us 1. Okay, so we have 2 raised to power k plus 1, and there are 2 raised to power k. So this is 2 times 2 raised to power k minus 1. This is 0 and this is 1. So you must have seen that we have attained what we wanted to, what we were aiming. Since the bases are same here, so you can multiply them. So it's 2 raised per k plus 1, 2 raised per k plus 1 minus 1, 0, 1. So we have shown that this third step, that this is true for n equal to k plus 1 here. Okay, so now the time to write the statement. So I'm just going to cover this area here for the statement here. Okay, so we would say, okay, as it is true for n equal to 1, and if true for n equal to k, then n equal to k plus 1. So it is true for all n. I'm just writing all n because it is not mentioned here that what kind of number is this n. Okay.